Algebra 2, here is lesson 15. And lesson 15, we will be graphing again, so if you have graph paper, that would be great. Lesson 15, solving systems by graphing. Now, please know that a system means that in this case, I'm going to have two equations, and they will contain two variables. A solution, hopefully, and there are three types, sorry, I should go over, there are three types of solutions. And I'm going to quickly go over them. So let's say I graph two lines. If they intersect at one point, so they have that means, and I would identify where they have one solution. And if I was to classify, I would call this consistent and independent, meaning these equations are independent of each other. Sorry that is crooked. The next possible solution is that my two lines, the two equations that I graph, are going to be on top of each other, meaning they're almost basically the same line. In this case, if I have two lines, lines are identical, then I would say that there are infinite solutions. And I would classify this as it's still consistent because you have a solution, but they are dependent on each other. Okay? Your last possibility are two lines that are parallel. And in that case, since they don't intersect and they don't overlap, there is no solution. So in that case, this is the only one that is inconsistent. Okay, so you can probably leave that one as just inconsistent. So here we are. We're going to go ahead and solve a few, and we'll do them together. The book goes over a couple different methods. The only method I want you to use is graphing. Okay, so if a problem asks you to build a table, ignore and graph. Okay? Now, you can use Desmos for this. Enter both equations on separate lines. So the top equation, the top line, enter your equation, the second line, and it'll tell you exactly where they cross. But if you're going to do this by hand, here we go. 3y minus x equals 9, and y plus x equals negative 1. Okay, the first thing we're going to do is get them both in slope-intercept form. Which is y equals mx plus b. So that's what I'm going to do first. So I'm going to graph, I'm going to rewrite this top one. So 3y, I'm going to add x to the other side, and then I'm going to divide by 3. And so y equals 1/3 x plus 3. Okay, so there is the first one. Let me move this up a little bit. Now I'm going to do this one. I'm going to subtract x from both sides, so negative x minus 1. and we're going to graph them. So make sure you are super, super careful when you graph these because you need a ruler. You need to make this as accurate as possible because you're trying to identify their point of intersection. So please be really careful. So here's positive 4. Here's negative 4. This is the y-axis. Here's x. There's negative 4, negative 2, negative 6, 2, 4, 6. So I'm going to color code them. I'm going to graph the one in black first. So my y-intercept is positive 3. I have a positive slope, so up 1 and to the right 3, up 1 and to the right 3. Go back to your starting point, down and to the left 3, down and to the left 3. So then I'm going to connect these. I'm going to draw arrows through the ends. And there we go. Okay, now I'm going to graph the red one. The red one has a y-intercept at negative 1. And I have an invisible slope, right, of negative 1 over 1. So that means I'm going to go down 1 and to the right, down 1 and to the right. I'm going to go in the opposite direction because I bet that they intersect right there. So the main thing that you need to do is identify where they intersect. Okay, so I have one solution, and that solution is right here. So I have one solution at negative 3, 2. And that is my answer. Now, if you were to classify this, I don't think in lesson practice, yeah, they don't really have us classify, but there is the first problem. Okay. I'm going to do 2 more with you, and then we'll do the lesson practice. I just want to make sure there's plenty of practice because it tends to be a difficult topic for some people. So here we go with the next one. All right, so I have 2x minus y equals 6 and y plus 2x equals negative 10. Remember, the easiest way to graph is to rewrite these in slope-intercept form. So here I would subtract 2x. Notice when I subtract it, I just write it on the other side with a subtraction sign. I have to get rid of the negative in front of y, so I'm dividing each one by negative. So that would give me y equals 2x minus 6. It changed both of these signs. This bottom one, I'm simply going to subtract 2x, so negative 2x minus 10. So now we're going to graph. Notice I have larger numbers, one all the way down at negative 10. So I'm going to leave room for negative 10, and I need to leave room for negative 6. So I need to make sure I go 2, 4, 6, 8. Oh, good. We have room for negative 10. And then up here, if you want to, I'm going to put one number here on my x-axis and one number here. So I'm going to graph the black one first, my y-intercept. So remember this is my y-axis. On y, I have a point at negative 6. My slope is 2 over 1, and it's positive. So up 2 to the right, up 2 to the right, down 2 to the left, down 2 to the left. And next one in red, my y-intercept is at negative 10, and I have a negative slope, so up 2 and over 1, up 2 and over 1, up 2. And notice we went right over the point of intersection, and so I am now going to put a line through those. And again, I have one solution. You look straight up, that's at negative 1, and the y value is negative 8. Okay? Now, I think we're going to go ahead and jump into our lesson practice. Oh, and that was your lesson practice. This is part A. So, sorry, I didn't realize I just did. Lesson practice is on page 103. All right, so let's go ahead and do B then. Now, B asks us to build a table, but like I told you, building tables takes forever. And it wants us to, I'm just going to skip B. So part C, 5x minus 6y equals 36, and 2y minus 3x equals negative 4. And I'm going to guess I need to move that up, yes. All right, so let's rewrite these. This would be negative 6y equals a negative 5x plus 36. I'm dividing each part by negative 6. So y equals 5, 6x minus 6, because a positive divided by a negative is a negative. Leave your slope as a fraction. It makes it really easy to do rise over run. And now for the bottom one. I'm going to write the bottom one in slope-intercept form. So 2y equals 3x minus 4. Divide by 2. Y equals 3 over 2x minus 2. So I'm going to graph these, and I don't know exactly where they cross, so I'm going to make sure I leave lots of space. So 2, 4, 6, 8, 10, 12, 2, 4, 6, 8. Here's my x-axis, here's y. So the blue line, my y-intercept is at negative 6. I'm going to go up 5, 2, 4, 5. Now I'm going to go to the right 6. Again, down 5 to the right 6. Next one in red, my y-intercept is way up here at negative 2, up 3 over 2, down 3 over 2. Now some people stop right here. Why would you stop? Keep graphing your lines so that they're near each other. So down 3 over 2. And I feel like I messed up. No, I didn't. Down 3 over 2. See how I had to keep going, and it did take me forever, but keep going until they intersect. So these two lines, if you look straight up, intersect at negative 6, and that is at negative 11. All right, next part of a lesson practice is super easy. They have us classify based on their shape. So part D has us classify and name the solution. So in part D, if you look at the book and you want to pause, the solution is at negative 3 and 3. And I would classify, since it has one solution, look at those pictures I drew at the beginning of your notes. It's consistent and independent. In part E, notice in the book, part E are parallel lines. So in that case, I would say no solution or inconsistent. And part F, the lines are overlapping. So I would say infinite solutions. which means they are consistent and dependent. Okay. And then finally, the last one is a word problem. And I'm gonna have us skip, and we're done.